Hi there, this is Professor Eckhouse. I'm going to talk about graphing linear equations today. And we're going to start by locating an object on a map using coordinate directions, which is the same idea as what we do when we graph a point on an XY axis. So this is where we're starting because it's something a little more familiar. So imagine that they created this grid system and put all of these different buildings in it, and nothing's quite this square, but just bear with me here. So let's look at the library. So the library, we would go over to 2, right? And then so we'd go over to 2, and then we would go up to C. So the library is at 2C. Okay, so the 2 is like the X, and the C is like the Y, if you're familiar with that at all. So just take a moment, pause the video, and try to label each of these with the grid location that it's at. Okay, so the parking garage, we'll start up there, is at 1A. Taylor Hall is at 1C. Administration is at 2D. And if you got any of these wrong, pause the video and try to figure out what you did wrong. Student Center is at 2B. The engineering building is, you go over to 3, so it's at 3 and you go up to B, 3B. And the stadium is at 4D. Tiger Field is at 4C, and residence halls are at 4A. So that's how you would do that. Very similar to what we're going to be doing with an XY axis. So first we have to talk about the coordinate plane. So the coordinate plane is basically two lines that go on forever in both directions. One is horizontal, the other is vertical. The horizontal is called the x-axis, and the vertical is called the y-axis. We talk about these 4 different sections, so this section here, and so on, as quadrants. This one is called quadrant 1, and we use Roman numerals. This one is called quadrant 2. This one is quadrant 3, and then the last one is 4. And this one is quadrant 4. And Roman numeral 4 is a IV, like that. All right, this right here is called the origin, where the 2 cross. All right, an ordered pair is a pair of numbers that are x and y. X being the x coordinate, and y being the y coordinate. And this is the coordinate plane. So the x and y coordinates are similar to right up here. We had 4D or 2D or 2C. Those are the coordinates. 2 and C would be the x and the y. All right, so let's plot some points on a rectangular coordinate system. So let's just plot, let's say, 3, 4. So what you're going to do is you're going to come over 3, 1, 2, 3 to here, and then you're going to go up 1, 2, 3, 4 to there. Another way to think about it is we would go over 3, a 1, 2, 3, right here, and go up, and over here this is our 4, and we would go over, and it's where the 2 come together right here. So there's just a couple different ways to look at it. Different people have been taught in different ways in different places, so however you want to do it. The first way is generally how I have learned to do it. So I'm going to go over 3, and then up 4, and that's my point 3, 4. Okay, so where it ends up though is here is my 3 and here is my 4. All right, so let's try a couple more. What if we had -1, 2. Try that. -1, 2. All right, so you would go -1 to there and up to 2, right there. So this is my -1, and there's my 2. So we would label it as -1, 2 if we were going to label. So what about, let's see, -4, -2. Let's try that. Try plotting that one. So we're going to go -4 this way to 4, and then down 2 right there. So there's my -4, and there's my -2. All right, so we're going to get lots of practice with this, but you try plotting the following points on the coordinate plane. Pause the video and give it a try. Okay, so 1, 4, you would go over to 1 and up to 4, and you would end up right there. So this is 1, 4. And where's 4, 1? So 4, 1 would be over to 4 and up 1. Okay, so positive numbers go up, negative numbers go down, positive numbers go right, negative numbers go left. So let's summarize that. So if we have x to the right is positive and left is negative, and for y, up is positive and down is negative. And we always start at the origin. All right. So identify the quadrant where a point is located. So let's plot these points and then identify which quadrant it lies in. So I'll do the first one with you, and then if you could pause the video and try them, that would be great. So -3, 4 would be 1, 2, 3, and then 1, 2, 3, 4 right here. So there's -3, 4. So that is in quadrant, I'm just going to use a Q, quadrant 2. All right, you go ahead and pause the video and try the rest. All right, so 2, 5 would be right here. Got to count over 2. So there's 2, and then up to 5. So there's 2, 5, and it is in quadrant 1. All right, the next one, 1, -3, we would go to the right 1 and down to -3. That would be here. So 1, -3, and that is in quadrant 4. All right, and then we've got -2, -1. We come to the left 2 and down 1. Always do x first. So -2, -1, and that is in quadrant 3. Okay. So plot these on the coordinate plane and think about how the signs affect the location. All right, so I've got -4, 2. -4, 2 is here. -4, 2. So that is negative, positive, and it ended up in quadrant 2, right there. -4, -2. -4, -2 is right here. -4, -2, and look how symmetrical it is. And that's negative, negative, right? I'll put it in parentheses so it looks like a point. And so that is quadrant 3. 4, -2. 1, 2, 3, 4, -2 is here. 4, -2. And that one is positive, negative, and it ends up in quadrant 4. And then 4, 2 is going to be here, over 4, up 2. And that is quadrant 1, and that is positive, positive, quadrant 1. I don't know why I didn't start with 1. I was being random, but anyway, there we go. Okay, so notice the signs. Negative, positive is quadrant 2, negative, negative is quadrant 3, and so on. Okay, so let's think about it just with the picture. The sign patterns of the quadrants. So this one is positive, positive. This one is negative, positive. You continue and label the other two. So quadrant 3 is negative, negative, and quadrant 4 is positive, negative. So you can tell where it's going to lie just by looking at the signs and picturing which way you're going to go. I wouldn't memorize it. I would just picture which way you would go. All right, what if one coordinate is 0? What do you do then? Well, you just don't move, right? So if x is 0, don't go left and don't go right. Just stay where you are at 0, 0, and then count up or down for the y. So let's look at 0, 3. So 0, the first 0, means I don't move left or right, so I stay right here. And then I'm going to go up 3, up to 3. Okay, so that's how that works. So 0, 3 is right here, 0, 3. All right, you try the rest and see how you do. These are surprisingly hard, so give it a try and really do graph them and see what happens. All right, 0, left, right, 0, so don't move left or right. Then -2 is up, down, so you're going to go down to there, and that's going to be 0, -2. All right, 4, 0, we would go right 4 and up or down 0, so we stay right here. So that is 4, 0. -1, 0 would be -1 to the left, and then don't go up or down. 0 is the y value. It means you just don't move up or down. So that is -1, 0. And where is 0, 0? 0, 0 is the origin. So this is called the origin. So that is 0, 0. All right, so points with a y coordinate equal to 0 are on the x-axis. So let's move this up and so we can look at it with the graph. Points with a y coordinate equal to 0 are on the x-axis. Let's look at which ones that was. The y coordinate equal to 0, that's those two. That was this one and this one. Are they on the x-axis? Yes, they are. All right, then points with an x-coordinate equal to 0 are on the y-axis. X-coordinate equal to 0, x-coordinate equal to 0. That is on the y-axis here and here. Okay, so y-coordinate equal to 0 on the x-axis, and to make this straighter, x-coordinate equal to 0 are on the y-axis. So they have a coordinate of 0 and some number b, and the y-coordinate on the 0 on the x-axis looks like this, some number a, comma 0. So if the y value is 0, it is on the x-axis. If the x value is 0, it is on the y-axis. Okay, so now just name the ordered pairs of every single one of these points and see how you do. These are good to just test yourself because it's so easy to make little mistakes. So pause the video, please, and try all of these, all A through Y. All right, so A, you should have gotten 4, 3, and always use parentheses around it. B is -4, 7. C is -8, -6. D is 6, -4. E is 8, 0. F is 0, -8. G is 0, 0. H is -3, 0. And I is 0, 8. So make sure especially you got the ones on the intercepts. They're called intercepts when they sit on the x or y axis. Make sure you got those correct, because those are the ones that give people the most problems and are really important to be able to do certain things in algebra. All right, so verifying solutions to equations in two variables. An equation in the form ax plus by equals c, where a and b are both not zero, I should say. One of them can be 0, but they can't both be 0, or so you don't have an equation anymore. It's called a linear equation in two variables. All right, so the word linear means it is a line when you graph it. Linear means line. So looking at this linear equation in standard form that I highlighted in yellow, and then look at this equation in example 6, what is A, what is B, and what is C? So A is always in front of A is always in front of x. So A equals 2. B is always in front of y, and so B equals 5. And the number by itself is always C. If you look up here at this if you look at this equation right here, you can see what everything is. A is always the coefficient of x, B coefficient of y, C constant. So C is 10. All right, next we need to write an equation that's not in standard form in standard form. So let's write standard form right here, right above it. AX plus BY equals C. So as you can see, the x is over here on the right side and it needs to be on the left. So I'm going to rewrite this a little bit bigger. I get y equals negative 3x plus 7, and I'm going to add 3x to both sides. So I'm just going to say plus 3x over here. And I get 3x plus y, because we always go in alphabetical order, equals 7. All right, so now we have it in standard form. It looks like this form right here. So we're going to name all of the parts. So A equals 3. B is the number in front of y right here. Well, there's nothing there, which means it's a 1. It's not a 0. If it was a 0, 0 times y is 0, y would be gone. It's a 1, so be careful. B equals 1, and C is the constant, so C equals 7. Okay, so if you'd just chosen it without rearranging it, you would have gotten A incorrect because it's a negative and it needs to be over on the left side, which makes it positive. All right, a solution to a linear equation in two variables. An ordered pair xy is a solution to a linear equation if the equation is true when x and y are substituted in. Okay, so let's check this one out. Determine whether negative 3, 5 is a solution for this equation here. So this is our x value and this is our y value, and they need to go in right here and right here. Okay, so just make sure you've got that really clear. And here's, I always make sure to put a parenthesis when I'm going to plug something in just in case it's negative, which one of them is, so be really careful. So the x is negative 3 and the y is 5. So we get negative 18 plus 10 equals 4. Is that true? Negative 8 equals 4. No, it does not. So it's not a solution. So not a solution. All right, so let's try 0, 2. So we've got 6 times x plus 2 times y, which we're going to put in. I started to write a y. Don't write a y because you're going to put the new y in. So the 0 goes here and the 2 goes there. We've got the x and the y. So 0 here, 2 here. So it's nice to get a 0 because it's just going to go away, right? You don't really even have to write 0 plus. It goes away when you say 6 times 0. If you need to write it, then write it. But if you don't need to, you don't have to do that. So 2 times 2 is 4. So 0 plus 4 equals 4, yes. So 0, 2 is a solution to the equation. All right, example 9. Select the ordered pairs pairs that are solutions to the given equation. All right, so how are we going to do this? You're just going to try every single one. So negative 5, 7, and then 4, 8, and then 9, negative 4. And we've got 4 times x. I'm going to take out the x and just leave a blank. 4 times a blank x minus 8 equals y. And here we've got y equals 4 blank minus 8, y equals 4. And there are an infinite number of solutions. It just has to be the right combination of solutions, right? So we've got our y is the 7 and our x is the negative 5. So 7 equals 4 times negative 5 minus 8. 7 equals negative 20 minus 8. No, that is definitely not true. 7 does not equal negative 28. So no, not that one. I'm going to cross it out. No. All right, the next one. 8 is the y value. 4 is the x value. So 4 times 4 minus 8. 8 equals 16 minus 8? Yes, it does. 8 equals 8. So this is a solution, yes. What about this one? Y is negative 4 equals 4 times 9 minus 8. Negative 4 equals 36 minus 8. Negative 4 equals 36 minus 8 is 28. That is definitely not a solution, no. So the only one we have here is this one. All right. So let's try the next one. Determine which ordered pairs are solutions. So now this is one way, is just to plug them in and see if something is a solution, if it makes it true. But falling on the line also means it's true. So everything on this line, before we begin, every single thing on this line is a solution. If you plugged any of those into this equation right here, and that is the graph of y equals 3x plus 4, anything you plug in is going to make it true. So let's try it. So let's look at the first one, 1, 7. So 1, 7, so no, not that one. Okay, I'm going to erase that. Next one, 3, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 lands right there. So yes, and I'm going to leave that one on there. 0, 4. Let me try, what color do I want? 0, 4. So I've got 0 and I go over, oh, there it is right there. So yes, that one is. 5, 7. So 5 and then go up to 7. No. All right, you pause the video and try the rest. All right, let's try the next one. Negative 2. 5 is up here, so no, not that one. Negative 4, 0 is right here. Yes, that one. Negative 7, negative 2 is right here. So no. Negative 9 and negative 5 is right here. So yes, that one's on the line. So the ones that land on the line are solutions, and you could go plug them into the equation to see if they make it true, and all of those will make it true. So pause the video and give it a try if you want to. Okay, create a table of ordered pairs, solutions to a line. So before we were given the ordered pairs, and now we have to find ordered pairs that are solutions. We have to find them ourselves. So we're going to use those points then to graph the line. So we're going to complete a table to find 3 solutions to this equation right here. So honestly, you can just pick any numbers for x, and then you find y. So we've got y equals 2x plus 3. So I am going to choose for x, I'm going to choose negative 2. I usually do a negative, maybe a 0, and then a positive, and I can get on both sides of the line. I usually do 3 points just to see if they all fall in a line, because then I catch my mistakes. All right, so I've got y equals 2 times negative 2 plus 3. So that is negative 2 times 2 is negative 4, plus 3 is negative 1. All right, negative 4 plus 3 equals negative 1. So that one is negative 1. That means my point is negative 2, negative 1. All right, so let's go find that point. Negative 2, negative 1 is right there. All right, the next one I picked was 0. 0 is easy. I like 0. So I get to say y equals 2 times 0 plus 3. Now 2 times 0 is just 0, so it goes away, and the answer is 3. Okay, so I get 3. Let me use my colors. So I get 3 here, and I get 0, 3. All right, 0, 3 is right there. All right, so now I'm going to try 2. I try to be symmetrical around both sides of the y-axis. So I go 2, and I'm going to have y equals 2 times 2 plus 3. So I'm going to put my 2 in, and I get 4 plus 3 is 7. So I have 2, 1, 2 to the right, and then up to 7. And that looks like a line to me. So, oh, I forgot to put my point in there. So I got 7, so my point is 2, 7. All right, so in general, this is going to look like that. So that's how we graph the line from the points we generally find. You can graph a line with 2 points, but it's better to find 3, just in case you made a mistake. All right, one more kind of topic here is we're going to find solutions to linear equations in 2 variables, and I'm going to show you how to do it using the intercepts. And what I mean by that is we plug in 0 for x and we plug in 0 for y to get 2 different points, one that crosses the x-axis and one that crosses the y-axis. All right, so I've already put in zeros here, 0 for x, and so let's try that one. And notice this works really well when the line is given in standard form. This is like the way to do it if it's given in standard form, is find zeros for x and then for y. All right, so let me show you what I mean. 2 times 0, because we're plugging the 0 in for x, and we're going to find what y is. 5y equals 20. Well, look at that. That just goes away. 5y equals 20. Divide both sides by 5, and I get y equals 4. So y equals 4 right there. All right, so my pair is 0, 4. All right, 0, 4. That's where it crosses. Remember, when x is 0, this is going to be the y-intercept. So it crosses the y-axis. Remember, this is the y-axis, and this is the x-axis. All right, so let's do the next one. The next one, we've got a 0 for y, so we've got 2x plus 5 times 0 equals 20. Well, 5 times 0 is 0, so that goes away. Anything plus 0 is just itself. So now we've got 2x equals 20. Divide both sides by 2, and x equals 10. All right, so x equals 10 here. And our pair is 10, 0. Now, it's a good idea to find a couple more points, so you can really find any 2 other points you want, and I challenge you to do that. I'm not going to take the time to do it here, just so my video would be very, very long. So just find 2 other points just like I did previously, and you're probably going to get some fractions, and that's okay. And in class, we'll probably take more time to do that. So we've got x equals 10 and y equals 0, so we've got this point is here, right there. Just double checking my work here, 10, 0, yep. Okay, so my line is going to go through here-ish, like that. Yeah. And like I said, it's a good idea to pick more points, so you can just choose something and see, and you'll probably, like I said, get a fraction. All right, so you know, I just changed my mind. I want to just show you at least one. You can skip forward if you don't want to see it, but I want to show you how to do just one more. So I'm going to choose 5 for x. 5 for x. So I get 2 times 5 plus 5y equals 20. And I get 10 plus 5y equals 20. See how y0 is so much easier? Subtract 10, and I get 5y equals 10. Divide by 5, and you get y equals 2. So y equals 2, and my point is 5, 2. So I come over here, and I find, look, there it is. So it's right on the line that I drew. All right. So find 4 solutions to the equation. Mostly I'm interested in you learning how to do the intercepts. So we're going to start with those. So x is 0 for the equation 5 times x plus 3 times y equals 30. So 5 times 0 is 0. I'm going to write it down this time so you can see what I mean, just in case you don't understand. So you don't have to say 0 plus, right? So we're going to divide both sides by 3, and I get y equals 10. All right, so y equals 10. All right, so 0, 10. 0, 10 is right there. I keep ending up with 10s. All right, so let's see. All right, so now I'm going to put in 0 for y. So I've got 5 times x plus 3 times 0 equals 30. Now, if I was doing this in class, what I would do is I would literally just put my hand over the 3y, because it's going to go away because it's times 0, and just say 5x equals 30. right? 5x equals 30. So solve that. And a lot of people can just go ahead and do that in their head because you're just dividing by 5. X equals 6. So 6, 0. All right, so I get 6, 0 as the other one. All right, so you can pick other points here. You can pick other points. So what if I chose 3 for x? I'm picking ones that are easy. But so we've got 5 times 3 plus 3y equals 30. And you may pick one that ends up being a fraction, like I said, but you can just kind of guess between points. All right, so I've got 15 plus 3y equals 30. So 3y equals 15, and now you see why I chose 3. So divide both sides by 3, and I get y equals 5. So 3, 5. All right, so 3, 5 ends up being right there, and that does look like it's on the line. And then I would just draw a line through all of these points. All right, last one. Why don't you try this one on your own? Okay, so I'm going to try the first one. I get 0 minus 3y equals 5. So the 0 goes away. I'm going to divide by -3, and I get y equals -5/3. Well, that's not pretty, but okay. Doesn't always work out perfectly. So I get 0, -5/3. -5/3 is 1 2/3. So I'm going to say 0, -5/3 is almost 6/3, which is almost -2. So right in there. All right, then we're going to do 0 for y. So I get x minus 3 times 0 equals 5. So this goes away, and I just end up with x equals 5. All right, so I've got 5, 0. All right, so 5, 0 is right there. Okay, so let's pick, what if we picked -5 for x, so we can check out what's going over on the left side. I didn't try this ahead of time. I'm just going to try it. It might be ugly, but we'll see. -5 is x minus 3y equals 5. So I'm going to add 5 to both sides, and I get -3y equals 10. Divide by -3, and I get y equals -10/3. Well, where is that? Well, use your fraction skills, and that's going to be -3 1/3. All right, so we've got, I did -5. That's what I chose for my x. And I got -10/3, or -3 1/3. So here we go, -5, -10/3. All right, so -5, -1, 2, 3, and 1/3 is about right there. It doesn't have to be perfect. And we get what looks like a pretty good line. There we go. That's how you graph with points. All right, thank you for watching.